In this video, we're going to prove that the function mu is multiplicative. Before we get into the proof, I want to say two different things. One, if you're into seeing mathematical proofs like this, you should most definitely consider subscribing to my channel, as that's all we do on this channel. The second thing I want to do is, in case you're not familiar with the mu function, is to define it. Mu of n, by definition, is the number 1 if n is 1. That is, mu of 1 is 1. And you get 0 if some primes, the square of some prime, divides n. And like I said, for some prime, there exists at least one prime where p squared divides n, sigma of n is 0. The other case is where phi of n is 1 to the r. And this is if n is equal to p1 times p2 all the way up to p sub r. It's negative 1 raised to the number of primes. Okay, and as I said, in this theorem, we're going to prove that mu is a multiplicative function. So again, this clearly does not need to be in the proof. So now, how about we let m and n be such that the GCD of m and n is 1. That's our criteria for a function to be multiplicative. Okay, suppose m is equal to p1 times p2 up to pr, and n is equal to q1 times 2q sub 2 up to q sub s. Now, since the GCD of m and n is 1, that should tell you something about the q's and the p's. Since the GCD of m and n is 1, that implies that no pi equals or qj. None of these none of those r primes are listed here. None of the q's are listed here. They're all different. That is, pi is not equal to pj for all i's and j's. I between 1 and r, and j between 1 and s. Okay, so now we have that mu of mn, which is mu of p1 up to pr times q1 up to q sub s, is equal to negative 1 raised to the number of primes. There are r plus s primes. But negative 1 to the r plus s is negative 1 to the r times negative 1 to the s. But that is equal to mu of m. That is, negative 1 to the r is equal to mu of m, because m has r primes and the powers are never more than 1, times negative 1 to the s. Well, that's can equal mu of n. Does it have to equal mu of n? No. It might equal q of w, mu of w, where w is T1 times T2 up to TS. But of course, I don't want to say mu of M times mu of W. That would be silly, because I want to show that mu is multiplicative. So I showed that mu of a product is mu of M times mu of N. And that's exactly what I needed to show, that mu is multiplicative. If you like seeing proofs like this, consider subscribing to my channel. Please click the like button, leave a comment. Hopefully I'll run into you in my next video. Don't forget, watch and learn.